Okay, we're going to find out B that compute under multiplication with A. Okay, normally in linear algebra, things don't really commute. What does commuting mean? Commuting means that if I take, let's take algebra for example. Just regular arithmetic. 2 times 3 equals 6. That's the same thing. You can flip the order of the two things you're multiplying. That's what commuting means. So you can commute them under multiplication. 3 times 2 also equals 6. So these two expressions are equivalent. That's all it's saying. So linear algebra, that's not the case. A times B is not equal to B times A, necessarily. Okay? What this is saying here is it wants us to find every matrix where it does commute under multiplication. Okay? Since it's not going to be all of them. So we need to find a situation where A times B equals B times A. We need to figure out what B would be in this case. All right. So that's essentially what we're doing here. So, how are we going to do this? Okay, let's take B. Let's represent B as a matrix. It has the same shape, A, B, C, D, so 2 by 2. And we don't know what these variables are. We don't know what these elements of the matrix are. All right. Now let's figure out, I think a good step would be to figure out what AB is and what BA is, okay, in terms of these variables. So let's do some matrix multiplication. So AB equals, let's take A, 1, 0, 2, 1, times B, which is A, B, C, D, and multiply that through. Remember, matrix multiplication, we're going to take the rows times the columns. So let's start first row, first column. Okay, 1 times A is just A, plus 0 times C. So which is just 0. So A plus 0 times C, 0. So just A. All right, next, first row, second column. 1 times B is B. And again, we get 0. So we're just going to get A and B on the top. So they're kind of lonely up there. Next, let's take the second row, first column. Let me erase these columns. Second row, first column, 2 times A is 2A. 1 times C is 1C, or just C. All right. 2 times B, 2B. And then we get 1 times D plus D. We have figured out what AB is. Now let's figure out what BA is. So we're going to get a slightly different answer, but we're going to make them equivalent. The reason we get a different answer is because, again, matrices don't commute. It's really kind of tricky. If you're doing element-wise operations, then yes, but we're not. Multiplication is not element-wise. Is that true? I don't know. Okay, I'll just stop talking and I'll start doing more really slow matrix multiplication. A, B, C, D. That's matrix B, and we're going to times that by matrix A, which is 1, 0, 2, 1. And we're going to get another matrix. I gave myself almost too much space before, but let's stick with it. Okay, first row, first column. A times, did I do this one right? Yeah, I did. Okay. A times 1, A. And then 2 times B is 2B. So A plus 2B. Okay, first row. Okay, we did the first column. Now first row, second column. A times 0 is 0. B times 1 is just B. So we get B right here. Okay, so we did that. Pretty good. Now let's do second row, first column. C times 1 is just C, plus D times 2, which is 2D. All right, now second row, second column. C times 0 is 0, plus just 1D. Okay, now I have both these matrices. And we could form a system of linear equations and solve this with Gaussian elimination. However, There's just so many free variables. I get confused. It's going to be a homologous system because each of these elements are supposedly equal to each other, right? It'd be a homologous system, lots of free variables. It'd be a little bit confusing for me. That's a route you can take. I'm going to simplify it and then just work with the system of equations directly. So to simplify it, let's just look at this expression that we have up here. We're looking at when AB equals BA. Now, what we can do is we can subtract BA from both sides. And then we minus BA over here. All right, and then on this side, we get these guys cancel out, and then we get AB minus BA equals the 0 vector. Okay, this is a square vector, it's not just 0. 2 by 2 with all zeros. So we can simplify this. All right, so let's just take the two matrices. A. Do I want to write it all out? It's probably better if I do. A, B, 2, A plus C. I notice that if I don't write it all out, then I can make a mistake. I can't keep very many things in my head at once. So best to write it out. C plus 2D. Okay, D. And now those two both equal 0, but let's just do an equal sign and solve for it over here, and then put that back up there. Okay, we have A minus A plus 2B. Distribute the negative, we get negative A plus, well, actually minus 2B. So A minus 2B. So the two A's will cancel, and we get negative 2B. 2B or not 2B? Negative 2B. Okay, next we have B minus B. Wonder what that equals. It equals 0. So we get 0 there. Now for this one. 2A plus C minus, now I'm just going to distribute beforehand. Let's not. Let's keep it simple. Distribute negative C minus 2D. Mathematicians do things really quickly, like all the time, and I think that's good, but sometimes when you're learning math, it's above your head, which is basically my experience always. It can get over your head. It can get overwhelming really quickly. All right, the two C's, they're going to cancel out. So now we get 2A minus 2D here. Okay, and last and least, just kidding, minus D. All right, these two D's are going to cancel out. We're just going to get 2B here. So this bad boy equals 0. It could also be a bad girl. Whatever you want. Okay, it's math. It doesn't have a gender. Okay, so negative 2B. I need to shut up. So we can get out a system of linear equations here. We have negative 2B equals 0. That's this first one. We have 0 equals 0. No, that's true. That's good. 2A minus 2D equals 0, and 2B equals 0. And remember, what we are solving for is our B matrix. Do not forget that has this order: A, B, C, D. So we need to find these variables. We can put them in there. Okay, 2B minus 0. Well, we can divide by negative 2. Negative 2. Cancel. 0 divided by negative 2. We have B equals 0. All right. So that means let's create our final B matrix right here. Our answer. B equals. Let's look at this guy right there. B. That is equal to 0. Now let's take a look at this one. 0 equals 0. Okay, thanks. That tells us nothing. I think that tells us that there's a free variable. Okay, 2a minus 2d. So if we add 2d to both sides, then we get 2a equals 2d. Divide both sides by 2. Okay, whatever a is, it is equal to d. So a equals d. We don't know what they are. So let's just put a placeholder in there. I think what's going on here is we're seeing that there are a lot of options here. We can plug in whatever we want for a and d, just so long as they're the same. So let's just represent that with whatever we want. Let's represent that with an x, okay? Whatever these two guys are, we're playing tic-tac-toe over here, they're going to be the same, okay? All right, now, last, we have this one, 2b equals 0. That's basically the same as the other one, b equals 0 again. All right, so what happens to our last variable? What happened to c? Well, when we did this, c just dropped out. Ooh, zooming in. Okay. So what that means, and I don't understand this perfectly, okay, but I can do it. So if you guys have a good explanation for why, let me know. I'm learning. That's why I'm making these videos. C drops out. So that means C is a free variable. I think that's what it is, and C can be anything. So since C is different than A and D, which are equal to each other, then we can just put a Y here. Okay. Now let's check to make sure that this is true. If this is true, that means A times B, right here, A times B equals B times A. Let's check to see if that is real. And if that is real, then we're good. So what is A again? A is 1, 0, 2, 1. So let's see, A times B equals B times A. Let's test that. A times B, now that we know what they are, A equals 1, 0, 2, 1, I hope. Yep. And B, which we have, stop it, over here, B is x, 0, y, x. So let's plug in whatever we want for that. I'll plug in 2 for x, so x equals 2, and should I do 1 or 0 for y? Let's do 0. Y equals 0. All right, we can plug anything in apparently. 2, 2, 0, 0. All right, let's clean up some room. And let's do it. Okay, matrix multiplication. So, first row, first column. 2 plus 0 is 2. First row, second column. 1, 0, 0, 0. That's a 0. All right, second row, first column. 2 times 2 is 4. 1 times 0 is 0. So we get a 4 here. All right, second row, second column. 2 times 0 is 0. 1 times 2 is 2. This is what AB equals. Okay, now let's see what BA is. If we're wrong, then we're not going to get the same matrix if we flip these around. Let's flip them around. 2, 0, 0, 2. 1, 0, 2, 1. All right. First row, first column. 2 times 1 is 2. 0 times 2 is 0. So we get 2 here. Wow, it's the same. Things are going great. All right. First row, second column. 2 times 0. 0 here. Things are going great. I'm so dumb. You're probably a graduate student, or you're probably just like a college engineering student, you're like, what the hell is he talking about? Okay, 0 times 1. 0. 2 times 2 is 4. Wow. 0 times 0. 2 times 1 is 2. Wow, it's the same thing. It turns out our matrix is right. So yeah, that's how you would solve for a volume system. This will work if you have a larger system, and you can also use Gaussian elimination to do this instead of just subtracting and simplifying and then getting a linear system of equations and solving from there. But it depends on what you like to do. So if you have any questions, also if you have a better explanation of why C right here, it can be any variable, feel free to let me know. Some free variables. Maybe one day I'll know. So, because maybe you'll tell me. Yeah, thanks. Bye.